AS interface from Pepperl+Fuchs is proving itself in the automotive industry. With its new factory in Rüsselsheim, Opel has set new standards in production technology. Using AS interface, up to 400 new Vectra models have been rolling off the assembly line each shift since the beginning of 2002. Utilizing a finger-shaped plant layout enabled the Vectra's final assembly to take place on a single production line without buffer zones, a logistical task of significant proportions. From unloading delivery vehicles to the processing on the assembly line, everything runs just in time. This saves space and reduces storage costs, but requires perfect timing and a reliable control process. Under these demanding conditions, ASI shows its full potential every day. The complete final assembly consists of 10 interconnected production lines, which employ overhead and floor conveyors. Process availability has top priority. Each production line has a typical length of approximately 100 meters. This means that there are always 300 vehicles in production, as shown here on the monorail carrier system. AS interface is used to connect a wide range of sensors and other input devices. Information from several thousand sensors is collected by over 1,700 ASI modules, processed by more than 140 ASI masters, and used to control every step of the assembly process. During each process step, the car bodies are lifted to a comfortable work height for the employee. The carrier heights are determined by over 300 ASI intelligent absolute value rotary encoders with cable pulls. All standard sensors on each overhead carrier are connected to ASI modules in a switch box that is an integral part of the monorail carrier. Sliding contacts transmit all signals between the ASI modules on the monorail carriers and the fixed position ASI masters. As a result, the integrated ASI modules are constantly assigned to new ASI masters. The ASI modules are reassigned in single carrier segments, which means that only one overhead carrier at a time is electrically connected to the master performing the automatic readdressing of the ASI modules. A trigger sensor detects the arrival of the overhead conveyor. Next, the ASI master readdresses the ASI nodes. The ASI master indicates this process by a yellow LED. During this process, the number of ASI modules is determined, and new addresses are assigned in a specified sequence. A second trigger sensor initiates an address verification procedure before the overhead conveyor leaves the single carrier segment. Then, the process starts all over again. The readdressing of the ASI modules can be seen here again, followed by assignment to the next segment. The green carrier with the ASI modules leaves the single carrier segment and is then assigned to the following control segment. Since it is now assigned to the ASI master controlling this section of the conveyor, it is depicted in blue. This reassignment occurs when the sliding contacts come into contact with the fixed contact rail. Here, 3 overhead carriers with differently addressed ASI modules are present in one control segment. Because the contact rail divides the conveyor into control sections, each ASI master will only detect ASI modules with allowable addresses 1 through 30. Although AS interface is restricted to a segment length of 100 meters and a maximum of 62 modules in each segment, the system architecture implemented at Opel allows ASI to be used on the approximately 1,000-meter long production line. The success of AS interface in this application is based on separation of the line into segments with automatic readdressing. The reliability of ASI, even when used in conjunction with less than perfect sliding contacts for signal transmission, is a perfect solution. Body and chassis marriage is performed easily, and ASI is seamlessly integrated even on such a large scale. Inductive sensors identify the floor carriers, and lateral drives push them onto the conveyor track. The unrestricted topology of AS interface makes installation simple, flexible, and inexpensive. In order to optimize space on the assembly floor, the AS interface components are installed in overhead-mounted junction boxes. This allows optimum transmission of all signals from the Pepperl+Fuchs ASI modules and masters to the higher-level field bus. Once the underbody work is complete, the vehicle is transferred to a floor conveyor. The ASI modules are conveniently located under the wooden panels of the floor carriers. The connection to the ASI 2-wire communication and 2-wire power lines are again implemented as linear sliding contacts. Electrostatic charges caused by friction are grounded using discharge brushes. Here is the system control center. The ASI masters and ASI power supply units are housed in one control cabinet. The automatic readdressing of the ASI modules is indicated by the address digits in the display and the yellow configuration LED. Extensive diagnostic functions speed up diagnosis and response times. Maintenance work is possible during operation and minimizes downtime. For example, with plug-in connection terminals, it takes only 20 seconds to replace a defective master. The doors are among the last components to be installed. In the event of an obstruction, an overrun monitoring system switches off the drive reliably and quickly to prevent damage. The final components are installed in the engine compartment. Then the vehicles roll to the test center for final inspection. A computer tests all major systems and components. Ultrasonic sensors monitor the vehicle's position and allow the next vehicle to access the test center. The new Vectra undergoes a final road test on a test track in order to check the chassis and suspension. Then the vehicle leaves assembly and is transported to its new owner. In this ambitious project at Opel Rüsselsheim, collaboration with Pepperl+Fuchs and the use of straightforward and reliable AS interface equipment has proved to be a very successful solution. This is why many other users also appreciate the benefits of the AS interface.